In this lesson we're going to look at another way to calculate the area between two graphs. Instead of calculating area 1, working it all out from the upper function, and then the area of 2, working out the area of the lower function, and then doing a takeaway, we can do something different at the start. This allows us only to do one integration instead of two. So before we start, we can just take away the functions from each other. We can do the upper function, take away the lower function first, and do a bit of algebra to stop us needing to do two integration calculations. So to do this, what you need to do is you need to make sure you know which one the upper function is. It needs to be the upper function, take away the lower function. Remember, look between the two limits, the upper and the lower limit, and see what function is the highest in the y-axis. So pick any point between the two. So if I pick this point here, I'm saying which is the highest bit. The blue is higher than red, so the upper function is the parabola. So this is the same question as the last time, and I'll just show you it gives you the same answer as the calculation we did in the last example. So the upper function is 9 minus x squared, and we're taking away more than one term, so you must put it in brackets, taking away x plus 2. If you don't put it in brackets, you will get it wrong. Because we're taking away all of this here, then you have a takeaway x and a takeaway 2 when you multiply this bracket out with takeaway. So what we get there, if you multiply this out, because we get 9 take away x squared, take away x, take away 2, we do the 9 take away 2 to get 7. Now that we've got that, we can integrate this new function between negative 3 and 1, the 7 minus the x squared. If we can integrate this correctly, then we will get the answer instead of doing two separate integrations. So a bit of algebra at the start, upper function take away lower function, and then one integration sum. So if we integrate this, integrate the 7 to get 7x, add 1 to the 1 power here, which is x to the power 1, so half x squared, add 1 to the power, a third x cubed, between 1 and negative 3. Sub in the 1 to all three bits, take away, and then sub in the negative 3 to all three bits. That will look like this. So we have to sort this all out. So that's going to be 7 take away a half times 1, which is just a half, take away a third times 1, which is just a third. So we've got 7 take away a half, take away a third. Subtract, and then you're going to have negative 21. That's going to be 9, half of 9, 9 over 2, or 4.5. And then you're going to have negative 3 cubed, so that's negative 27. A third of that's negative 9, so that'll be a plus 9 at the end. So then negative 21, take away 4.5, and a plus 9 from this part here. So to work all this out, what you could do, you could do a variety of things. You could work this out, change it all into sixths, and do it that way. Or you could basically multiply the bracket out by negative 1. So 7 take away a half, take away a third, that's going to get to plus 21, plus 4.5, and a take away 9. When you end up with that situation, then you end up having a look at all the whole numbers first. So look at your 7, look at your 21, and your take away 9. So that's going to come to 28, take away 9, which is 19. If you then turn your attention, so we're at 19 with the, I'll leave those in actually, we're at 19 so far. If you turn your attention to the 4.5 and the half, take away a half. So we're at 19, and then that's just going to come to 4, isn't it? So 19 add 4 is 23. So we're at 23, and if you take away a third from 23, you get 22 and 2/3. And that's the answer. 22 and 2/3. And if you look back at this slower way of doing it, upper area, take away lower area, we got 22 and 2/3. So two ways of doing this calculation. This one only involves one integration.